Today I'm going to show you how easy it is to use our MicroTouch USB hardware to make a custom USB capacitive touch keypad. Today we're going to use a simple piece of metal tape. Now this metal tape is found at the hardware store. It's just an aluminum tape for ductwork. You could use copper tape. Anything conductive is fine. What we're going to do is take this tape, make a sensor out of it. This sensor is we just cut a square piece and soldered a little wire to it. And then we're going to solder the wire sensor to the channel 1 of our MicroTouch USB hardware. Let's go ahead and attach this sensor to a piece of glass. We've got an 1/8 inch thick piece of glass here for our demonstration. I'm going to peel off the liner and stick the sensor here. That's it. And we're going to plug in the hardware to the USB port. There you go. The next thing we're going to do is launch the Fast Touch configuration utility. First thing it asks us to do is to agree to the licensing agreement. So you can sit and read through all those legalese. Hit agree, submit. The next step is to choose what hardware we're going to be using. In this case, we're going to be using our new MicroTouch USB. So we'll select that from the list. Click OK. I had soldered this sensor to channel 1. So we're just going to click channel 1. There's nothing else, no other sensors. So that's it. We're going to hit save. And we get this pop-up menu. It says, do not touch the capacitive touch buttons while saving your button configuration details. And this is because it's going to take some baseline readings. So you really don't want to touch the buttons. You don't want to move anything. You want to leave it alone in this step. Just takes a few seconds and you'll get your baselines. Then you're ready to proceed. The next step is to choose your noise filtering methods. We're just making a very simple keypad here, one button, nothing crazy going on. So we'll just choose the default settings and move on. Okay, the next step is our tuning. So we're going to hit quick start. We're going to get our little graph here. I'm going to go ahead and touch the button. Wow, you get a really good threshold here. It's going to say finish. It's going to say threshold was found to be 42. You can go to the next channel or redo this channel. If you didn't do it right, or you felt you messed it up, you can always go and click the redo button and start again. I think we did a great job here, so we're going to move on. And that's it. We only had one button. So for this demonstration, we're going to make a USB keypad. We could easily choose UART and make this a serial keypad. But we're going to choose USB, make it simple. Now, this is the fun part here. We can map this button to any key on a computer keyboard, combination keys like Shift 2, that would give you an @ or Shift 3 would give you the #, hashtag. You could choose any joystick button like these hat switches or X, O, triangle, L1, R1. You can choose anything you want. We even have the keyboard multimedia keys here. These are great. You could see we've got play, pause, record, rewind, next track, previous track, mute. You even have launch calculator, launch email. You know what? Let's use launch calculator. That's kind of neat. Let's choose that and see how it goes. So we're done here. Hit save. Move on. Do you want to use the debug LEDs? This particular board does not have debug LEDs, so we'll just say no. The Go pins, Go debug configuration. Go is interesting. Go stands for general output. So this particular PCB has 12 output lines. We could map this button press to any of those output lines. We could get an active high, active low, a momentary response, or a toggled response, toggle or latching response. But for this demo, we're just going to say no and move on. The next thing that we could do is map this button press to some feedback. You could use a piezo buzzer, or one of our boards has a audio player, so you could play different sounds. You could map different sounds to different button presses. You could even do tactile feedback with this. But again, for this demo, we're going to keep it simple. We're going to say no, none, save. We're going to move on. Okay, so the next thing is we save this configuration and tuning values into a file. And so we're going to call this foil demo. And yes. Okay. Now what's nice about this file is you could make 100 of these things. You don't have to go through all these steps again. You can just load the file. You go to File, load this file, and you can save that into all your boards. It makes making more of these very easy. Next step is to program the board. Now we're done. Super easy. Okay. So at this point, what we need to do is disconnect the board and reconnect the board. What that does is take it out of the configuration mode and put it into the run mode. So now if we touch this button, we should see a calculator show up. There you go. How cool is that? We can try it again. So you can see we made a custom capacitive touch keypad. We even made the touch sensor out of conductive foil, foil tape. You could have used anything conductive. You could use the stapler on your desk and make that a button if you wanted with this tool, all without writing a single line of code. For more information, please visit our website, www.rapidkeypads.com, and keep an eye out for future videos showing more functionality and capabilities. Thank you.